All right, hey everybody. Let's see. That's not what we need. This is not BlitzJess. Sorry, I do not stream often, as you may tell here. All right, so my apologies here. I'm gonna wait a minute here and just see what happens here. So if you don't mind, just bear with me. I've got a picture of Arnold Schwarzenegger. I guess I should have changed that too. And say, okay, all right, perfect. I was looking for some chat. Hello, hey, nice to meet you all. Well, thank you. You're very, very kind. So, like I said, we'll start maybe here in just a few minutes. Hello, Phaser Beams. I like that name for some reason. So yeah, give me a few minutes. Like I said, I apologize. I am not the streamer guy. I've done a few in the past. I always did chess streams, to be honest. So, but we'll get going here quick enough, and we'll see how it goes. Certainly, of course, feel free to ask questions, all that good stuff. I am going to record everything, so your comments will be saved, if that's okay. And then the other thing, my tablet that's connected that I'm using to write on is a little touchy. So hopefully it won't disconnect or nothing weird will happen. But if so, that's the issue, and I'll try to get it going quickly. So my apologies there if that should happen. So, all right, we'll get going. Oh, hey, that's cool. And again, I am going to record this. So, okay, maybe we'll see what happens. Again, certainly if there is anybody out there, feel free to ask questions, all that good stuff. And you know, if not, I'm just going to start working through stuff and I'll entertain myself here. So again, the point of this review is this would be something kind of along the lines that I would do in calculus, maybe in the first week or two, just to do an algebra review. And I've said it in the past quite a few times. I know maybe I say it too much. The majority of people I saw that failed calculus was almost exclusively because of algebra. So, and I think the other people come in kind of overconfident in their algebra skills. I've seen that a million times as well. And it ends up being kind of a shock for them, and it's not a pleasant experience, you know. And as an instructor, you don't want to see that either. So I'm telling you, please, if you're not positive about your algebra abilities, make sure to go over them. It really is the backbone. But again, this could also be used for anybody going into pre-calculus. Maybe you need a review for statistics. Maybe you're taking test prep. You know, you just need an algebra review. Maybe you're helping your kiddo. I don't know. It's obviously not going to be in depth. There's going to be things missing, but feel free to ask questions. I'm going to add things, fill in gaps. I had a link to the questions I'm doing, so hopefully you saw that. If not, I will again post it. Like I said, I kind of had some issues with just getting everything set up earlier, so I'm a little behind schedule. But okay, let's jump into it. So I am kind of watching the live stream here as well of myself, and it looks like it is a few seconds behind. So I've already scrolled up here, and looks like it's about 10 or 12 seconds behind where I'm actually talking live at home to myself. So if there's a delay in me answering you, that's the only reason. So let me adjust my camera there real quick too. And I may even just get rid of my camera. I don't know. Is it nice to have the camera there, or is it simply in the way? What do you think? It's nice to see a person. So, okay. Can someone do me one favor too? Can somebody say yes or no? Can you guys, I assume you all can hear me. Somebody would have said, I can't hear you at this point, so I assume that's okay. Okay, so the first bunch of questions that I'm going to go through simply have to do with solving different types of equations. So in this first part, I've got linear equations, quadratic equations, there's higher powered, there's, perfect, thank you, alpha, beta. There are absolute values, some absolute value equations, exponential, logarithms, quite a few different things. So let's just run through them. So first things first, let's look at our, this 2x plus 9 equals 4. And again, recall this is simply going to be a linear equation. And hopefully you remember how to solve linear equations. So to go through these, I try to, if there's parentheses and I have to do any sort of distributing, I would do that first. Notice in this case there are no parentheses. I don't have to distribute. But then what I try to do is put all of my numbers to one side. Anything involving a variable on the other side, I'll collect like terms and divide. So you'll see. So there's not a tremendous amount to do in this question. So on the left side, I see a positive 2x. I see a positive 9. And then on the right side, I see a positive 4. I think, well, if I could just move that positive 9 over, I would have the term involving the variable on one side. I would have the number on the other. And again, that ends up being good. So what I would simply do is subtract 9 from both sides. So remember, if we add or subtract a value to one side of our equation, we do have to do it to the other to keep everything equal. And maybe you all can help me keep track with my arithmetic. So this is going to be 2x. And again, the positive 9 and that negative 9, or positive 9 minus 9, is simply 0. We don't write it on the left side. 4 minus 9 is negative 5. So again, I'm thinking 2 multiplied by what number is negative 5? I want to get x all by itself. Well, since I'm multiplying by 2, to undo that, I'm going to divide the left side by 2. But then I have to do that to the right side as well. Well, on the left side, 2 divided by 2 is just 1x. That's what we want. And negative 5 over 2. A lot of people I know will convert these into decimals. I would definitely leave it as a fraction. You typically need to learn to work with fractions. I mean, it's a judgment call. If you're in a statistics class, I would probably turn it into a decimal. But in general, say in a pre-calculus, trig, calculus course, I would just keep it as a fraction. Okay, so there is our one solution. X equals negative 5 over 2. Nothing too bad. So the next one, again, the only thing that's different about the second one is, well, there's a couple things. Again, it's linear, because notice I only have terms involving x to the first power and then numbers floating around. Well, on the left side, I simply want to combine those like terms. So, okay, well, there's a couple different ways we could do it. I could get common denominators. Or you could do it a different way. Of course, they'll all give you the same solution. I'm going to do it a slightly different way. Sorry, my arrows got a little cut off there. So 2 over 3x, we could write that as 2x over 3. And then plus 4/5 x, we could write that as 4x over 5, still equals 12. And what I want to do is I want to multiply by some number. In this case, it would just be some number. I want to multiply by some number I want to multiply the left side, I should say, by some number so that I will get rid of my fractions. Yes, this will be uploaded. This should be saved. So you can come back and check it out later. So I'm trying to get rid of my fractions is all I'm trying to do. So what I'm doing is I'm thinking, what is the smallest number? What's the smallest number that is divisible both by 5 and by 3? I'm looking at those denominators. Another way to say that is I'm really looking at the least common multiple of those numbers 3 and 5. And notice, I think the least common multiple The first number that I can think of that is both divisible by 3 and divisible by 5 would be the number 15. So that's what I'm going to multiply both sides of my equation by. I'm going to multiply both sides of my equation by 15. And I apologize there, again, if my camera is cutting things off a little bit. Now the idea is I'm simply going to distribute that 15 to both terms on the left. And maybe, again, so it may feel like I'm writing out a couple extra steps, and I guess I am, but I would rather have more steps versus fewer. So typically this next step I certainly wouldn't do. I would probably immediately simplify, but let's write it out. So I'm distributing my 15, which I could write as 15 over 1. And I'm simply saying, well, 15 over 1, we're going to multiply that by 2x over 3. Okay. I'm not actually doing it. I'm just saying that's what we have to do by writing it down. No problem. I'm going to do that again. I have to distribute, so I would have 15 multiplied by 4x over 5. And on the right side, okay, 15 times 12, I can do that. That looks like that's going to be 180, if my arithmetic is correct. Now the idea is we can cancel. So I'm looking at 15 divided by 3. Again, that's why we picked the number 15. So 15 divided by 3, that's really the same thing as the number 5. So really, I'm looking at this first part. In my head, I'm saying, well, that's really just 5 times 2x. So the 15 divided by 3 is 5. 5 times the 2x. That's going to leave me with 10x. And then I'm going to do the same thing. So there's my plus sign. So now I'm thinking, well, 15 divided by 5, what is that? Well, 15 divided by 5 is 3. But we still haven't done anything with the 4x. That's still being multiplied. So 3 times 4x, that's going to be 12x equals 180. Well, now I have like terms on the left side. 10x plus 12x. Well, that's like having 10 apples plus 12 apples. 10 apples plus 12 apples is 22 apples. 10x plus 12x gives you 22x. I cannot speak today. My apologies, I did not get much sleep. Okay, so 22x equals 180. And now the same thing as before. We're basically at this step where we had to divide by the coefficient. Before we had 2x equals -5. We divided both sides by 2. Well, now we're multiplying not by 2, but by 22. So I'm going to divide both sides by 22. Again, on the left side, 22 divided by 22 is just 1x. That's the whole point of doing that. And again, I would simplify the right side if I could a little bit. I certainly see that both of these numbers are even. So if I simplify the numerator, 180 divided by 2, that would be 90. 22 divided by 2, that would be 11. 11 is a prime number, so I know that this doesn't reduce, and I've got my answer. Okay, so a little bit of overkill, but again, and the reason why I'm taking a few extra steps, a couple reasons. Two main reasons. One, people, even when they get to calculus, they don't like fractions, so learn to work with them because you'll have to. And also, too, this idea of getting rid of fractions, like when we distributed by this 15, we can use that idea to solve some equations as well. So that's why I'm doing that. All right, let's keep going. So how's everybody out there? We're going gangbusters out there. We've got 30 people. All right, so going crazy. I hope everybody's enjoying this nice Saturday. It is very hot where I am. So I am hiding from the sun today, at least for now. I've got big plans this evening, though, so that's exciting. Okay, so let's jump on to the next question, number 3. So here we've got x squared plus 6x plus 8 equals 0. Well, what type of equation is this? It's not linear because I see this power of 2. And when I have this type of equation on the left side, this power of 2, recall that this is called a quadratic equation. And a quadratic equation can have at most 2 solutions. It's possible to have one solution, and it's possible to have zero solutions. And that's in terms of real numbers. And again, typically, at least in calculus, we still often restrict ourselves, at least in the courses I taught, we restrict ourselves to real numbers. Okay, so quadratics. Usually for me, when I solve a quadratic, I just do one of two things. I usually try to factor first. This is my own personal preference. For the kind viewer out there, do whatever you like. I either try to factor it, and if that doesn't work, I simply use the quadratic formula. Those are my go-tos. So for factoring. Now notice this is a special case. Recall that when that coefficient in front of x squared is a positive 1, I can do something sort of special to try to factor it. So I'm going to try to factor this one. So notice the right side is equal to 0. This is a very important thing I should point out as well. Whenever we have a quadratic equation, before we start factoring, we want one side of our equation to be equal to 0. That is crucial. If the right side was not equal to 0, say I had a 3 on the right side, the first thing I would do is subtract 3 from both sides of my equation so that then I do have a 0 on that other side. So that is very important, and you'll see that. So, okay, I recognize that, but it's definitely worth pointing out because I certainly see people where they don't do this, and then they start just doing they do something similar to what I'm doing, and it's a very common but very, very wrong mistake. So again, make sure the right side is 0. Okay, so let's go back to what I was saying. What is the trick? The trick is I'm looking for two numbers that multiply. You want them to multiply to the constant, which in this case is positive 8. But you want those two numbers, so I want two numbers that satisfy these criteria. They multiply to positive 8, but they add up to whatever the coefficient is on the term involving x, which in this case is positive 6. So I'm thinking I need two numbers that multiply to positive 8 but add to positive 6. Okay, can I do that? Well, let's see. To multiply to positive 8, again, using whole numbers, I'm either going to use 1 and 8 or 2 and 4. 1 and 8 clearly doesn't work. 2 and 4. Oh, that sounds good, because if I use, say, positive 2 and positive 4, right, those two numbers multiply to positive 8, and they also add up to positive 6. So jackpot. That's good. Now, to get the x squared, I'm just simply going to need an x and an x in each set of parentheses. And the idea is, if we distribute this out, if I take x times x times positive 4, positive 2 times x, positive 2 times positive 4, and if I collect all those like terms, again, I'm getting back that I would simplify and get x squared plus 6x plus 8 equals 0. So again, I have factored. That's good, okay, because once I factored, it gets much easier. And it gets much easier because it reduces to two linear equations. So the idea is, if I have two numbers, right, if I have something times something else, and I get 0 out at the end, what has to happen? Well, either A has to equal 0, or B has to equal 0, or maybe both, right? Maybe both, but at least one of them, that's what we're saying. Right, if two numbers multiply and you get 0 at the end of the day, either one or maybe both is 0. And this is why it makes sense to, this is why you have to have 0 on the right side. Because suppose I didn't have a 0 here. You know, suppose I had 3 here. And then I'm making the same argument. Well, I've got two numbers that multiply to 3. Does it have to be true that either A is equal to 3 or B is equal to 3? No, that does not make sense at all, right? That's not correct. So that's the idea. That logic just doesn't work. But if we do have two things that multiply together to 0, yes, it makes sense to say one or the other, or maybe both is 0. And that's why we can say, well, if I can make the stuff in the first set of parentheses equal to 0, or if I can make that stuff in that second set of parentheses equal to 0, if If I can find the value of x that does that, then I've got my solutions. Well, now I've got two linear equations. X plus 2 equals 0. I could simply subtract 2 from both sides. That would give me x equals negative 2 as one solution. And from the second one, x plus 4 equals 0. I could subtract 4 from both sides and simply get x equals negative 4 as my other solution. So I've got two solutions. Now the question didn't ask for this at all, but if I think about that original expression on the left, and I'm going to write it as y equals x squared plus 6x plus 8. Notice what we've really done here is we've found the x-intercepts by going through this process. We found the x-intercepts by going through this process. And recall that a parabola, which is what you're going to produce when you graph a quadratic, you're going to get a parabola, recall, and a parabola either opens upwards or downwards. So remember that, that's the rough shape of a parabola. Recall that if the coefficient on the squared term is positive, like in this case it's a positive 1, it's a positive number, that means our parabola opens upwards. Well, what we've done is we've found the x-intercepts on that parabola. I know that there's an x-intercept at negative 4 and at negative 2. That's what these two numbers represent in terms graphically. Now, I don't know how far it goes down, right? I don't know if it goes all the way down to here, or I should say just a little bit down. I don't know if it goes way far down here. Maybe it's kind of a more, steep, if you want to call it that, like parabola. Well, I could figure that out, though, because the vertex, by symmetry, has to be in between those 2 points. So that low point is going to occur at negative 3. So I could even plug negative 3 in. I could find the corresponding y values. I could also plug in, say, 0 into this expression. Notice if I plug in 0 for x, I would get y equals 8. I'm now finding the y-intercept. So if I plug in x equals 0, I would have y equals 8. So already, okay, so I didn't find that y value. I could by plugging in negative 3. And now, okay, that's supposed to go through 8, and that's supposed to go through negative 4, and it's supposed to be a parabola, and it's supposed to be symmetric. Okay, so that would be a way to even graph your parabola. So notice this question didn't ask about graphing a parabola, but if somebody said, if the homework question was graph y equals x squared plus 6x plus 8, and you glanced over at your friend Patrick's homework, you would see me doing all of this stuff first. That would be the first thing I would be doing. I would try to determine if there's any x-intercepts. Okay, so again, though, back to the moral of the story. You've got a quadratic equation. One side is 0. The coefficient on x squared is 1. In that case, we look for two numbers that multiply to the constant but add up to the coefficient on the, we say the linear term, just the variable x to the first, or whatever your variable to the first is, x to the first in this case. We use that to factor, set each factor equal to 0. Okay, great. We're taking a long time to do these, aren't we? So Patrick, speed it up. Okay, let's speed it up a little bit. I don't think so, actually. I'm going to take my time because why not? Number 4. So 3x squared plus 5x equals, and I think I'm actually going to skip the next one because it's almost the same. We'll do it real quick. So let me do it how I did it. 3x squared plus 5x plus 14 equals 0. Okay, so now the same thing. I'm thinking, do I want to try to factor it, or do I want to use the quadratic formula? Now again, there's other ways to do these. You could use factor by grouping. I would never ever solve one of these by factoring by grouping personally. Now the thing that gets tricky about this is the coefficient on the x squared term is no longer a positive 1. So we couldn't say, hey, are there two numbers that multiply to positive 14 but add up, say, at a positive 5. That doesn't work. Don't do that. And again, the whole reason is that coefficient on the x squared, it has to be a positive 1 to do that. I could still play around, though, if I wanted to try to factor. If I wanted to try to factor this. So to get my 3x squared term, I'm going to use an x and an x, because when I distribute, that's going to give me my x squared. Now I need two numbers that multiply to give me positive 3. Is it positive 14? Okay, there is another one. Okay, so 3x squared, it is negative 14. Okay, thanks. So let me change that then. You're saying that should be minus 14, Rosalind? If so, I appreciate you. I'm too lazy. Let me look, actually. I did pull it up. Hey, I was smart enough to do that. Thanks. No, let's see. It's 3x squared plus 15, at least on this one. I think number 5, the next one does turn into a negative, if I'm correct. So I think I'm okay on this one. If I'm looking correctly at the link. So 4 and 5 are similar. 5 will turn into 4 with the sign difference. Okay. So back to this one then. Okay. So, but thank you, because I absolutely will do that. So I appreciate it. So to get the positive 3, the only whole numbers I could use would be 3 and 1. So that's nice, because if I had like a 20, like say 20x squared, it gets so in the next one, we will move it to the other side. That is correct, Rosalind. And number 4, I believe the way I have it set up is it's already equal to 0, though. In my like my set of review questions is what I'm saying. I hope I'm understanding you correctly. The next one we will move. So the next question, let me just put it up here real quick. It's 3x squared plus 5x. And then I have that equal to 14. And I think okay, perfect. We're on the same page. Okay. So as I'm saying, 4 and 5 are extremely simple. So, okay, excellent. But I will do that one real quick next. Same idea, though, and we'll use the exact same idea. So, okay, so on this one, 3x squared plus 5x plus 14 equals 0. To get the 3, again, I know it's a 3 and a 1, but say it was like 20x squared. I could use a 1 and a 20. I could use a 2 and a 10. I could use a 4 and a 5. Already I've got like, sort of 3 sets to think about. Well, to get the positive 14, I know I either need a positive and a positive or a negative and a negative, but the middle term is positive, so I know they both have to be positive. Well, to get a 14, I could also use to multiply it 1 and 14 or 2 and 7. Now, the issue is when I plug in 114 here, I could switch those and I could do the same thing with 2 and 7. You start getting a lot of different possibilities, and I don't want to think about it. Sometimes I will, simply because I tend to be relatively quick with arithmetic, so I know I can do it quickly and it works for me. If you're at all slow with arithmetic, okay, don't do it this way. Don't brute force it. So instead, what I'm going to use, and this is the other moral of the story, and this is exactly what we will do in number 5. I'm going to do the same thing. I probably won't even work it all the way through. We're going to use the quadratic formula. And this says if you have a formula ax squared plus bx plus c equals 0, it says the solution, I should say solutions, are going to be of the forms x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is a formula that I would say you should certainly have memorized. And I saw somebody made a comment about using a calculator, and I'm like, okay. I always told people if you don't know how to do it the long way, it's very kind of stupid in a way maybe. If you don't know how to do it the long way, you should be doing it by hand. You should learn how to do it the long way. You should know why. If you know how to do the long way, then just use a calculator. But if you just use the calculator without knowing how it works, it's going to come back and bite you, for those of you that are going further. So it is something to keep in mind. It's not I know some teachers get annoyed by that. It's a reasonable answer. It's a reasonable thing to say, I think. Okay, so in this case, I'm looking at my 3x squared plus 5x plus 14. So a is going to be whatever number is in front of the x squared, which is going to be a positive 3. Again, take into account the signs. Now, all of mine are positive, but I am being careful about it. B is equal to positive 5, and C is simply going to be equal to positive 14. And if they don't factor nicely, typically you're going to get weird numbers. Not always, but let's see. So let's just plug that in. So I've got negative of the b value, which is 5. Okay, and I realize that the negative is the parentheses are not necessary here. I have found that some students like them because, for example, if your b value is negative, they like to see that in the parentheses. So maybe you like that, maybe you don't. Whatever floats your boat. Okay, so again, b squared, so that's going to be 5 squared minus 4 times our a value, which is 3, times our c value, which is 14. So if you're observant, you may already notice something, and I certainly do. So then we've got 2 times a, which is 3. So the thing that I am noticing in this case is I'm looking at all of this stuff underneath the square root. And you may remember the name of the stuff underneath the square root, this b squared minus 4ac. It's got a special name. And that is known as the discriminant. You'll see that terminology a little bit. I would say you'll be able to make it through most of your career without say, what's the discriminant? And they'll say it's that stuff underneath the square root in the quadratic formula. And they'll say, okay. But notice the discriminant in this case. Notice it's going to be a negative number. So notice that my 5 squared, that's going to be 25. 4 times 3, that's already 12. Times 14, I know that this is going to be less than 0, right? The stuff on the left side, this is going, I know that's going to be negative without doing much arithmetic, right? I don't care its actual value because it doesn't matter. I just care if it's positive or negative. It's clearly going to be negative, and that's what that statement says. It's less than 0. That's how we say that. Well, if it's less than 0, that simply tells you if that discriminant is less than 0, it simply says that you have no real solutions. So in this case, that would be my answer. I would simply say this original quadratic equation simply has no real solutions. Okay, that's it. Because of the discriminant, we're going to get something negative. Again, if you've seen complex numbers, or they're also called imaginary numbers, you know, the little I, you know, if you've seen the little I, you can certainly simplify it, and I never really liked the term imaginary because people are like, oh, they're fake. I mean, they're no more fake than 2 or 3 or 5, so I always like the term complex numbers, but that's what we would use. Okay, so let's look at the difference between this one and number 5. So I'm going to go through this one a little quicker. 3x squared, it was the same thing, right? Almost 3x squared, we were just talking about it, and I wrote it down. 3x squared plus 5x equals 14. Okay, and as my friend Rosalind was pointing out there, in this one, we want to make the one side of our equation equal to 0. So we will start off by subtracting 14 from both sides. Well, on the left side, we'll get our 0, which is what we want. There's no like terms, so that minus 14, I can't really do anything with it other than just to tack it on. And that's fine, just tack it on. But now the same idea. You could go back and you could try to factor. You could go through all of this trial and error stuff that we did back up here. Maybe it works, maybe it doesn't. Knock yourself out. It doesn't. It doesn't. There's no way. Okay, so that shouldn't work. So I would simply do the same thing. I'm going to use the quadratic formula. So notice my a is still positive 3. My b is still going to be positive 5, just like in number 4. But now notice that my C value, instead of being positive 14, my C value is going to change to negative 14. Okay, so if I do my solution, x equals negative b plus or minus the square root. So we'll do b squared, so that's b we said is equal to 5, minus 4 times a, which is 3, times c, which is negative 14. Okay, we're going to be, oh, I wrote negative b and I didn't plug it in there. So negative b, so that's going to be negative 5, plus or minus b squared minus 4 times a times c. I think that looks good, all over 2 times a. Okay, so now I think we're going to be, we'll be okay in the sense that the stuff underneath the discriminant is not going to be negative. So in that sense, we've got some work to do. Okay, so well, let's just keep simplifying. So negative 5, well, that's just negative 5. So 5 squared, that is going to be 25. So I think, let's see, a negative and a negative, that's going to be a positive. So that's why I know, you know, we changed the sign on that C term. So I knew now we were going to get something positive. Let's see, 4 times 3 is 12. What is 14 times 12? Well, let's see. 10 times 14, that would be 140. 2 times 14 is 28. So 28 and 140, that looks like 168. Check my arithmetic. The denominator, 2 times 3 is 6. And again, let's just keep simplifying. Now it's just arithmetic. So 25 plus 168, what is that? 193. It looks like 193 over 6. And now recall that we can, this is where we get our two solutions, right? That's where that plus minus comes into it. It says one of our solutions is x equals negative 5. So I'm looking at my plus minus here. So one of our solutions is negative 5 plus the square root of 193 over 6. And my other solution is going to be x equals negative 5. And again, I'm looking at that plus minus. Now I'm going to use the other one, the minus sign. The square root of 193 all over 6. And, okay, you could simplify that down, and I will call it a day. So again, in this case, we got two solutions. And notice how much, in a sense, there was quite a bit more work just by changing the sign on that constant, because we were able to keep going through the quadratic formula a bit more. So okay, those are our two solutions. Not too bad. So let me pause here for half a second. I'm going to take a chug of my coffee. Raina? Rihanna? Sorry, I apologize. Hello, you're very welcome. So, all right, let's keep going here. We'll keep chugging along. I had one with trial and error that does work. I think I made one real quick. So it wasn't on there, so let me maybe do this one like real quick just to put it on there. I think I made one that did work. 3x squared plus 13x equals negative 14. Just again to show you this kind of trial and error stuff. I would still do the same thing. So I would start off by adding 14 to both sides. So I would have 3x squared plus 13x plus 14. Did this work? We'll see. I keep switching colors. There's no reason, so don't pay any attention to that. My apologies. Okay, so let's see if we can't come up with some numbers that work. So again, to get the 3x squared, I'm going to use a 3x and an x. Now to get the 14, I'm either going to use 1 and 14, or I'm going to use 2 and 7. So I'm either going to have 1 and 14, I could have 14 and 1, or I'm going to have 2 and 7, or I'm going to have 7 and then 2. So again, lots of possibilities. But I think in this case that if I use a positive 7 here and a positive 2 here, I think that's going to work. Because notice when I no, that was not the right one. I've got them backwards, I think. Okay, let's try that one more time. That looks better, right? You're like, no, Patrick. So notice that when I multiply the 3x and the 2, I will get a 6x. And then the 7 times the x will be 7x. I'll have a 6x plus a 7x, and that is going to give me my 13x, the 2 and 7 make 14. Hey, this one factors. So this is my point. Do you want to go through this and trial and error and maybe get it to work? I don't know. If you can get it quickly, that was the trade-off to me. If I can get it quickly, it's usually faster than doing the quadratic formula. If I can't, then I've wasted time. So again, if there's a lot of factors, I usually just go to the quadratic formula because I know I'm going to get there. I keep hearing myself talk, and I keep hearing my accent coming out, my southern accent. X to the 4th minus 4x to the 3rd minus 21, x squared equals 0. Again, I have no idea how long I'm going to get here. I will say there's no way I'm going to get through all these questions. It's already 40 minutes. I'm on number 6. So let's speed these up. Okay, so when I look at this one, this is a polynomial. Anytime you have a polynomial, and this goes for a quadratic, I mean, linear equations don't factor. Anything that's a higher degree than a linear equation, I think about factoring. Again, notice, you always need to have one side equal to 0. So if I don't mention that for these types of equations, just be like, hey, it's understood, we know now. We know that we have to make one side equal to 0. And recall that this type of equation on the left, so degree 3 is cubic, degree 4, which is the highest power, those are called quartic. You don't need to know that. They're really just in general a type of polynomial. Linear functions, quadratic functions, degree 3, degree 4, degree 5, keep going. Those are all polynomials. They all share a lot of the same characteristics, so that's important. The first thing I think about a polynomial, again, after I know that it's equal to 0, the very first thing you always ask yourself, like period, is does it factor? Is there anything you can factor? If the answer to that is yes, then you do it. So notice in this case I've got x to the 4th, x to the 3rd, x squared. I think I could factor out x to some power. Notice the coefficients. I've got a 1, a -4, and a -21. I couldn't factor any number out there, so I think I'm just going to leave that. Now, recall when I factor out an x. So I'm going to factor out an x. Let me change that. I'm going to factor out an x to some power. And the power that I factor out is I look at all the degrees, and I pick the smallest power. So in this case, well, 4, 3, 2. 2 is the smallest power that I can factor out. Or excuse me, is the smallest, that's the degree I'm going to use. The smallest thing I can factor out is x to the 2nd power. And now I simply think, well, what goes inside here so that when I distribute, I get back that original thing on the left. Now notice originally too, I started with 3 terms on the left side. I've got 1 term, 2 term, 3 terms. When I factor something out, you're still going to have 3 terms. So I know I'm going to need 3 things in the parentheses. Well, x squared times x squared, if I multiply those, that's going to give me my x to the 4th. Let's see, I would need a -4, it looks like times x. So x squared times -4x, that's going to give me my -4x to the 3rd. And last but not least, I think we just need -21. We don't need any, we don't need to include an x there, because when we multiply, we'll simply get -21x squared, so that's good. All right, so now the question is, so we factored something out, that's our x squared. Whatever's left over, you have to ask yourself again, does it factor further? Maybe it breaks down further. And now I notice, well, this is really just a quadratic. And I know how to solve quadratics. I can either try to factor them, or I can use the quadratic formula. So the idea is I can take that first factor and set it equal to 0, and I can take that second factor and set it equal to 0. We're doing the exact same thing as when we had, as when we had linear equations. You got two things that multiply together to give you 0. Either the first thing or the second, either the first factor or the second factor has to be 0. Well, the first one's easy. If what number squared is 0, that's just 0. Again, you could take the square root of both sides. On the left side, I'm going to try to trial and error this. So I'm thinking two numbers that multiply to -21 but add up to -4. Let's see, I think -7 and +3 will do that. So if I set each one of those equal to 0, x minus 7 equals 0, x plus 3 equals 0, well, from my first equation, I could add 7 to both sides. That would give me x equals 7. And from my second one, I could subtract 3 from both sides, and I'll get x equals -3. And again, along with that other one we figured out, x equals 0, those would be our 3 solutions. Another thing to notice, whatever the highest power is on a polynomial, you can have at most that number of solutions. And in this case, I've got 1, 2, it looks like 3, but notice if you have x squared, I could really write that as x times x equals 0. Or we would say, well, either x equals 0 or the other x equals 0. And it looks like now, so really we would say 0 is a repeated root. We would say it has multiplicity of 2. Why are you telling me this? You may recall that if you know about the multiplicity of a root, it tells you what the graph looks like near that x value. So the multiplicity will play a role in the shape of a graph. It's something worth considering. Again, like somebody said earlier, use a calculator. That's nice, but hey, maybe you don't have a calculator and it's slow. If you have to break out a calculator for every single thing, it doesn't work. Okay, so let's keep going. If anybody has any questions, please stop me. I see people kind of coming and going. So number 7, I know this probably isn't the most thrilling thing on earth. So the absolute value of x plus 15 equals 8. Does anyone know? So how do you solve this? What do you do? What do you do with this type of absolute value? And again, especially those of you going into calculus, you won't see absolute value all the time. Absolute value, one of the ways it's described is it's talked about its relationship to distance. You can interpret absolute value as distance from something in a lot of cases. And that notion of capturing distance is going to be very important because one of the first topics you talk about in calculus are limits, which tie into derivatives. To do that, you need this notion of closeness or distance. Absolute value does that. Limits and derivatives are everything you do in calculus. So, okay, so Rosalind says set equal to 8 and -8. And yes, that's absolutely correct because recall the absolute value of something, right? The absolute value, the way I think about it, again, you can interpret it as distance. Just numerically, I think, hey, if it's positive, leave it alone. If it's negative, make it the positive of that number. And if it's 0, it's 0. That's, to me, absolute value. Well, again, I want the stuff at the end of the day. I want something at the end of the day, right? So if I take the absolute value of it, I want it to equal 8. Well, if the stuff inside the absolute value, if it equals 8, well, the absolute value of that is 8. Or if the absolute value, or if the stuff inside the absolute value equals -8, again, the absolute value of that will be +8. So both of those work. All right, we've got two linear equations. The first one I could subtract 15. 8 minus 15 would be -7. Sorry, I've got a little gnat in the house, a little fruit fly. And then I would subtract 15 from the second one. -8 minus 15, what is that, -23? Okay. Howdy, some guy. You're very welcome. Okay, so I don't know if I had this one in here. So let's make a little 7 star. What if the question said this? How would we go about solving that one instead? So the absolute value of x plus 15, instead of +8 equals -8. So why do we say or and? Okay, that's actually a very good question. It's kind of, I would say, the ambiguity in the English language. I mean, it's understood that they're both solutions. So it's like saying the solutions are x equals -7 or equals x equals -23. Or, I mean, to me, it's saying the same thing. You are absolutely correct, Rosalind. Math is very picky and very anal. It probably would technically be more correct to say and. So it sounds like one of those things too to somebody. It's like, oh geez, you're being so nitpicky, but it's not. It's important. So I think technically you probably should be saying and. So let me fix it. But yeah, I'm kind of using them interchangeably is what I'm doing. Okay, so like number 7 star. Yeah, that's what I'm doing. I'm just they're both solutions. So does the second one, the absolute value of x plus 15 equals -8? I'll give a couple seconds. Does anybody have an idea on what to do with this one? Okay, so yeah, so at the end of the day, right, you plug in something negative for x, or you plug in something for x, you add 15 to it, you take the absolute value of it. Is it ever possible to get -8 out after you take the absolute value of it? Well, no. So in this case, just like old Phaser is saying, this simply has no solutions, right? There's no number so that, right? There's no number so that we take the absolute value of that number, and at the end of the day, we get -8. There's no number that does that. So now, no matter what we plug in for x, and we get something inside of that absolute value, well, you're never going to get -8 out at the end of the day. Yes, so 7, yeah, these are both absolute value equations for sure. So yeah, I think you're already jumping ahead to number 8. So again, 7 star wasn't on there. That's why I put a little star. I decided to make a little extra side question. Is why I threw that on there. So 7 star is not on the little worksheet that I gave you. So again, my apologies. So let's look at number 8 because I think maybe that is what you're looking at again, Rosalind. So we have the absolute value of x plus 3 equals the absolute value of 2x plus 1. And this is what I always tell people too, because there's a lot of, yeah, in the same way, right? If we interpret absolute value as distance, it just can't be negative. So okay, there's no solution. A lot of people though will just sort of autopilot say, oh, we make it equal to the thing on that side, and then we make it equal to the thing on the other side, but we take the negative of it. So they would almost still be doing the same thing as in number 7. But again, if you stop and think about it, right, it doesn't work. And that's what I always tell people. You don't want to just memorize these rules because a lot of times there's just too many. But if you can understand them, that's good. Okay, so maybe we can even just set this one up. Maybe we don't have to go all the way through it because I think I'm getting long-winded per usual. So the absolute value of x plus 3 equals the absolute value of 2x plus 1. A, could that have solutions? And B, how would we go about finding those solutions? What would we need to set up in order to arrive at those values? So in this case, right, I think we could use kind of the same logic that we did on the other ones, right? If I can make the stuff inside the absolute value exactly equal to the stuff inside the absolute value on the other side, well, if I can make those two numbers equal, the absolute value of them is obviously going to be equal. So this would be one equation we would have to solve. And maybe I won't solve it. Well, okay, this one's so simple. Let's do it. Oh no, what happened? There we go. Okay, so we can solve this one easily enough. So I could subtract x from both sides and subtract 1 from both sides. It looks like we would get x equals 2. That would be one of them. Now, the other thing that could happen is, right, they could be equal but opposite signs. So I'm just going to put a negative on one side or the other. And notice it doesn't matter which side you put the negative on, because that's going to give you an equivalent equation. So in this case, we would have x plus 3 equals negative 2x minus 1. I could add 2x to both sides. That would give me 3x on the left. I could subtract 3 from both sides. Negative 1 minus 3 would be negative 4. And then I could simply divide both sides by 3. So a little bit faster there, just simply because we've been doing these. So, okay, just take the original one. Just take the stuff in the absolute value and set them equal, or set them equal but make one of them negative. Okay. Not too bad. Number 9. So now we're going to jump into stuff dealing with exponentials and logarithms. E to the x minus 4 equals 10. And the thing that you need to recall about exponentials and logarithms, again, you'll see these. One of the important things I should say, exponentials and logarithms undo each other. They are inverses of each other. So just like when we say addition and subtraction undo each other, right? You add 5, you subtract 5, those undo each other. Those are inverse operations. If you take a number and you exponentiate it, so use it as a power, you exponentiate it. To get that back, you have to use a logarithm. So that's the idea. So type of equation number 9, this is known because of this thing. This is known as an exponential equation. And an exponential equation is a number, it's when you have a number to a variable. So one thing to remember, okay, pi, we're not talking about pi, Patrick, I know. Pi is roughly equal to the number 3.14. Recall that e is a number. E is roughly equal to 2.79. Okay? So it's very much, we look at it like, a lot of people look at it and they're like, oh, e, they see it as a variable or something. It's not, or some like generic undefined number. It's not 2.7. What am I doing? Sorry, my computer's acting weird. So, what was I saying? So E is a very specific number. That's what we have to be careful about. So, and I'm going to do the graph here in just 1 second. I was trying to find one thing. And I wrote 2.79. What am I doing? 2.71. I'm losing my mind. So anyway, sorry. Let me get back to this real quick. Okay. Let's see. Okay. So the thing that you want to remember too, so the thing that's important, think about like x squared versus say 2 to the x. X squared, this is going to be a quadratic or polynomial. 2 to the x though, that's an exponential. And the graphs, 2.71. 2.719 is where the 9 came from. Thank you. So a polynomial and an exponential are very different types of equations. So that's something to keep in mind when you're going through this. The way you solve them and their behaviors are quite different. So recall that an exponential looks like this. So this is an exponential. If that number is larger than 1, and it's going to be decreasing if your base is between 0 and 1. We don't have negative bases, so keep that in mind. The other couple of properties that we're going to use here that are very important, So recall that if we take a raised to the log base a of x, we just get x back. And if we take log base a of a to the x, that also just equals x. So these are known as the cancellation laws. And again, I'm going through this quickly because I'm hoping you have seen this before. I know exponentials and logarithms definitely tend to cause people some issues. So at the end of all this, if people want to see some more exponentials and logarithms, I'm certainly happy to do that. Okay, so let's go back to our equation. What on earth do we do to solve this? So number 9. So we've got e to the x minus 4 equals 10. I think, okay, this is an exponential. I know how to solve that by, eventually I'm going to use logarithms if I have to. So I'm thinking about it in my head, kind of like it's at just x minus 4 equals 10. Well, I'm going to start off by adding 4 to both sides. So I get e to the x equals 14. And now this is where I'm going to utilize this cancellation property. I'm now going to use this cancellation property. So, okay, I've got e, it says e to what number equals 14? We can already guess, right? Because you're saying 2.71 raised to what power is 14? I mean, it's probably between, like 2 and 3. That would be my guess. But I'm going to use this cancellation property now. And what I'm going to do is, notice I've got e, instead of a to the x, I've got e to the x. Well, I have to use the same base. So on the left side, I'm going to use log base e. That's kind of my new part. I'm taking log base e of e to the x. And on the right side, I'm going to take log base e of 14. Well, on the left side, I'm now using this cancellation property. So log base e of e to the x, that's just the same thing as x. And log base e of 14, well, that is something you put into a calculator. And that would be my solution. One very important thing to point out, recall that when we have log base e, we use a special notation. We use ln. So log base e, this notation of log base e, and ln, those mean the exact same thing. It turns out that that number e, that e it's such a special number that when we use it as the base of a logarithm, we give it its own special notation to distinguish it from all of the other logarithms. But otherwise, it's just the exact same thing. All the properties are the same. So that would be my answer. You could type in natural logarithm of 14 into your calculator. You would get a solution. Okay. 10 is very much the same. It's only slightly different. I mean, to me, I look at it, I'm like, hey, it's the same problem. So 3 raised to the power of 2x plus 4 equals 18. You could do a little bit of simplification. Maybe it's even worth doing. It's completely unnecessary, but just to kind of remind you about some ways you could simplify. We could even write this as 3 squared raised to the power of x. Because, right, if you multiply the exponents, you still get 3 to the 2x. Well, 3 squared is just 9. So really, I have 9x plus 4 equals 18. So now, to me, this question looks identical to, number 9. Instead of a base of e, we have a base of 9. But other than that, it's the exact same thing. So I will subtract 4 from both sides. This gives me 9 raised to the power of x equals 14. Now, this is where we're going to kind of branch off for just a moment as well to point something out. So there are 2 different ways. It's going to look different. The answers are equivalent. So that's the magic. So one way to do this is so we're going to use logarithms in both cases. That's one thing I want to point out. I've got an exponential equation. I've got a variable. When you have a variable upstairs as an exponent, to get it down at some point, you're going to have to use a logarithm. So keep that in mind. If there's a variable upstairs, almost always, okay, I can make some counterexamples, but in general, if you have a variable upstairs, you're going to need logarithms. Keep that in mind. Vice versa. If you have logarithms involved in your equation, you're going to need to use some sort of exponential to help you solve it. Okay. So we can do the exact same thing. I'm still going to use this cancellation property, and the only thing I'm thinking about is I just need the bases to match, and then sort of everything just sort of collapses except for that exponent. So one way to do it is I could take, well, I could take log base 9 of the left side, and I could take, well, if I take log base 9 of the left side, I have to do it to the right side. But now by this cancellation property, we just get x on the left side, and that's my solution. Log base 9 of 14. Perfect. You could put that into Google or Wolfram or any number of websites, and that would spit out a number. If you have an old rinky-dink calculator, they're not going to have log base 9 on there. They're either going to have, so for calculators, a simple calculator, they'll either have log base 10, which is known as the common logarithm. We'll just write log. Or again, log base e, that's the natural logarithm. Those are your two choices. We could still use those. So I could take the natural logarithm of both sides. Now notice though my variable is still trapped upstairs. I want that to come down. And this is where we need to know some other important properties of logarithms. Some other important properties of logarithms. And one of those is if you have a logarithm, some base, you got something raised to some power, it says that we can pull that exponent out front as a coefficient. So that power comes out front as multiplication, is the property that you got to remember. Well, that's the whole point. That's the whole point of taking the logarithm. This property brings your exponent down. And that's good. So now we have x times the natural logarithm of 9 equals the natural logarithm of 14. And again, when you look at this, the natural logarithm of 9, that's just some number. The natural logarithm of 14, that is also just some number. I don't know what they are off the top of my head, but to me, like, sometimes when people see that ln, they kind of, ln of 9, they get nervous. I'm just like, to me, it just says some number times x equals some number. That's all it's saying. So don't be thrown off by that. Well, you know, if it said x times 5, what would we do? Well, we would divide both sides by 5. Well, it doesn't say x times 5. It says x times the natural logarithm of 9. So I'm going to divide both sides by the natural logarithm of 9, and that's going to give me my solution. And again, your rinky-dink calculator will certainly do natural logarithm. But anymore, it's almost outdated. The technology is pretty available. So, is that like the derivative chain method? Are you talking about derivatives in calculus? I assume so. Yes, there's certainly something. I assume you're talking about logarithmic differentiation. Yes. So in logarithmic differentiation, we use properties of logarithms, and we should even put the other ones down there. So some other properties. We use properties of logarithms to break things up. So yes, I believe that is what you are alluding to. So these are some of the other logarithm properties that you have to know. You will absolutely use these. If your teacher, if your instructor, again, if you're taking calculus, if you have a hard-nosed instructor, and they're going to expect you to bust all this out and know it without a second thought, and if you say, I don't remember it, they're going to say, you shouldn't be in this class. That's what they're going to say. So my point being, make sure you remember this stuff. Again, this is the hard thing about calculus. Like usually no one of these things is terrible, but it's all of them together. It's a lot. So yes, Rosalind, you are 100% correct. That's the main place I would say you would really. I mean, you'll certainly see logarithms and exponentials, um, just because e crops up and e ends up being so important. And the way they define it is in term of limits. So yeah, this stuff is coming. This stuff is coming. Okay. Okay, let's see. That was number 10. Let's see. I don't know how you all are feeling. I'm still going okay. Again, we've got a lot to do. So for those of you that are interested about seeing a follow-up to this, I don't know when works. I don't know if tomorrow works. I've got to be at the airport around noon, but I could do something tomorrow afternoon. So tentatively, maybe I'll do something tomorrow. I'll record it, and for those interested, and then we'll just see what happens. Okay, so number 11. So notice the difference in this one, right? It looks kind of like my others. My other equations had exponentials. I used logarithms. This has logarithms. So this would be known as a logarithmic equation. Guess what? To solve logarithmic equations, we often use we use exponentials. Is the idea to undo them. Can we do a follow-up to complete all questions? Yeah, I was definitely going to go through the algebra portion. Yeah, I feel like good. Thank you. I'm glad you like it. So we'll keep going. If nothing else, it'll be me and you, Rosalind. I'll do this. We can get together. But yeah, I'll try to do something. So yet another important property to remember for logarithms: log base a of x equals y. Recall we can convert that into exponential notation by saying a to the y equals x. So you can interchange these. These say the same thing, you know. So I always, whenever I have to evaluate a logarithm, I'm thinking about an exponential in my head is the way I'm thinking about it. So let's do this one real quick. So again, I've got this variable sort of trapped inside this logarithm. I'm going to move everything else over that I can. That's going to be my starting point. Well, I'm just going to subtract 8 from both sides. So that's going to give me log base 2 of x equals 4. And now I'm just going to use this, this switching to exponential notation that I jotted down here on the right. It says if we take the base and we raise it to whatever was on the other side of the equal sign, and then we set that equal to what was next to the base, that's how we get our exponential form. So in this case, it says that 2 raised to the power of 4 is going to equal x. Well, that's 2 times 2 times 2 times 2, which is 16. Again, be careful with your arithmetic. It's so easy to see 2 to the 4th and say 8. Just be careful, right? It's 2 times 2 times 2 times 2, which is going to be 16. So be careful there. But all I did was I got the logarithm by itself, and then I just turned it into exponential notation. I think 12 is identical. Log base 2 of x plus 8 equals 13. I don't know what my point was when I made this. But you could subtract 8 and have log base 2 of x equals 5. The same thing, that means that 2 to the 5th equals x. And 2 to the 5th is simply going to be equal to 32. That's it. Now, these are very basic equations involving logarithms. I want to say it real quick. Anytime you solve logarithms, you always need to be real careful and make sure that your solutions will satisfy the original logarithmic equation, because it is possible to get what are known as extraneous solutions. And I think we should see some of those at some point. So let's go on to our next one. Log base 2 of x plus log base 2 of 3x equals 4. Now, the question is, what do we do with with this one. And again, be real careful the way that you combine logarithms because people will sort of forget the rules and then, again, they kind of start inventing their own. So be careful about that. So this is where we're going to use this property involving addition of two logarithms. So I'm starting with the right side, and I'm going to group it back together into one. So what it says is if you have addition between two logarithms, again, as long as the base is the same, it has to be the same base. It says if that base is the same, you can put them as one logarithm, but instead of adding the things, they become multiplication. So I remember products turn into pluses, or pluses become products, whatever. That's how I remember it. So using that property, well, I'm going to group those two logarithms into a single one because, again, they're both base 2. And then I just take the x and I multiply it by the 3x. I just multiply those two things together, whatever it is. It could be simple, it could be complicated. Well, of course, I could simplify. That's going to be 3x squared equals 4. So log base 2 of 3x squared equals 4. And again, now I'm just going to use my properties. I can rewrite this and say, well, 2 raised to the 4th power equals 3x squared. I'm just using the same property that we did here, except now instead of just x, I've got 3x squared. That's okay. Well, 2 to the 4th, that's 16, equals 3x squared. I could divide both sides by 3. And lastly, I could take the square root of both sides. I would get positive, negative, square root of 16 over 3, which I could reduce to positive, negative, square root of 16 over the square root of 3. But I could make that just 4 over the square root of 3. But I could rationalize. And that's going to give me my solutions of plus minus 4 times the square root of 3 over 3. So does that look good? Random question, is your website down forever? That is also a very good question. I didn't really like the website at the end. Maybe people found it useful. I thought it was just to me it looked like I need a better way to navigate. So I need to bring it back. If you've noticed, I haven't been making videos, Giselle. I got pretty burnt out on it, to be honest. I certainly enjoy doing it, but work took me other directions. But like I miss it. I kind of enjoy this. Like I'm having fun right now, to be honest, with you currently 27 people. So I plan on bringing it back. Okay, back to logarithms. So does that look good for solutions for this question? Does that make sense? I look like a wild man. I'm looking at myself. I think, okay. Now, so let me ask a follow-up question here real quick. Why are the solutions I gave you not correct? So it's a trick question. Trick question. What's the problem? Yes, laser beams, the negative solution, right? So we kind of went through this arithmetic. Yeah, Rosalind, the negative. So this is why I said you got to be careful. And it's not like it's bad just because it's negative. What you need to do, right, is go back and look at the original. So I'm going to plug the values in here and the values in here. Recall, so I showed you, I talked about the graph of an exponential. Recall that a logarithm looks roughly like that. That's if the base is larger than 1. You can have logarithms with a base between 0 and 1, but in terms of applications, I can't think of where I've ever seen one. So they're just not very common. You really don't run into them. So that's the basic graph of a logarithm. But yeah, if you think about the domain of a logarithm, right? The domain of a logarithm is from 0 to infinity, not including 0. It's got to be greater than 0. So I think if I substitute in either of those two values for x, will it eventually produce a negative inside of the logarithm? Well, clearly, because there's no work to do, right? So the negative would mess up this one. It would also mess up the other one. So in this case, so the only solution is 4 root 3 over 3. So again, it's one of those things. I'm like, you've done all the hard work. Don't mess up the question on your quiz or test because you forget that part. And obviously, right, it is important. It's not like it's not important, but you get so happy, right? You've gone through it all. At least me, I'm like, yay, I got the answer. And then I'm like, okay, I'm gonna go on to the next one. And then you get it back, and it's like -3, and you're like, jeez. Very annoying. Those days were long ago. Okay, so 2 times log base 4 of x minus log base 4 of 3x to the third equals 4. Again, when you solve logarithms, you want to try to group them into one logarithm. That's the main idea. You want to group them into one logarithm. To group them into one logarithm, we want to start using these properties of logarithms. Now, to use those properties of logarithms, notice that the coefficients on the logarithms are positive ones. There's a positive 1, plus 1, there's a 1 here, there's a -1 here. There's no coefficients on the logarithms like we have in this case. So I'm like, okay, I want to group my logarithms together, but I can't because that coefficient of a 2. But I know what to do with coefficients. It says, well, exponents can come out as coefficients. Well, likewise, coefficients can go up as exponents. So I'm going to make use of that property and make that coefficient become an exponent. So I'm going to write my first one as log base 4 of x just to the second power. So that's all it changed, right? My 2 here has become my 2 here. Right, so there's my 2. The next logarithm, I'm not going to do anything to it. There is multiplication inside, and you could break it up into addition. That would be legal. But again, I'm trying to combine them, so don't do that. Yes, it's algebraically correct, but it's not algebraically useful, I think. Okay, so I've got a 1 here. I've got a minus and a 1. So now I can use this property of, so addition turns to multiplication. Subtraction turns to division. So I'm going to have x squared over 3x to the third equals 4. And then we can just keep simplifying. So this is going to be 1 over 3x, right? X squared over x to the third will leave me with 1 over 3x equals 4. That's going to give me 4 to the 4th power equals 1 over 3 times x. Oh boy, 4 to the 4th, that's 16 times 16, which is 256, equals 1 over 3x. You could flip both sides and get 3x equals 1 over 256. And now, last but not least, does this look right? It looks like we would have to divide both sides by 3. So, no one, you've got your 3 in the numerator, and I've got mine in the denominator. Which one of us messed up here? Did I mess up? It's certainly possible. I'm so sleepy. I don't think so. I think I'm okay. Hey, Deller. Yeah, you're very welcome. My pleasure. Absolutely. So that looks like a solution. Again, now I need to go back and make sure that if I plug that in, it doesn't produce a negative number inside of any of my logarithms. Well, if I plug in, okay, so that number is clearly positive. So I'll be okay here. And likewise, I'll be okay here. So that would be my solution. I'm in business. Hooray, hurrah. So yeah, you could multiply both sides by 3x, yeah, equivalently, and then divide by 256. So yeah, I think, okay, perfect. Thank you, no one. Yeah, no worries. That would be something I could have easily done. What happened? The third line. So are we okay here? Are we okay here? Is it this line you need? So if it's that line, again, we're using that property. So let me talk through it again real quick. So, okay, so the one after that or one before it? I hate this. There's like a delay in my relay. Go down 3 more. 1, 2, 3. This one? So I'm just doing 4 to the 4th on the left side. 4 times 4 times 4 times 4. That's 16 times 16. And 16 times 16 should be 256, if I'm correct. So I'm just simplifying 4 to the power of 4 to get 256. And then just leaving the right side 1 over 3x alone. And then just like you said, I'm multiplying both sides by 3x and then dividing both sides by 256 at the same time to get the second step. Or equivalently, you could think about flipping one fraction and flipping the other fraction as well to get 3x equals 1 over 256, and then just divide both sides by 3. Okay, perfect. Excellent. Alrighty, so yeah, logarithms. I think we've got, let's see, was there another logarithm? 14, okay, that looks good. Okay, so I think that was the last logarithm. So it looks like now it jumps into rational equations. How are you all doing? Do you want to keep going, or do you want to take a break, or do you want to stop and pick it up? It's been 90 minutes roughly right there. Rosalind, you're my audience. I'm going to defer to you since you're the one talking to me, mostly. No one, Phaser. I think you all are just here for fun. Let's take a break. Do you want to take a break and come back, or take a break and come back tomorrow? I can come back in a few minutes. I got nothing to do this evening right now. Another one, like another day, or come back in a few minutes? Come back tomorrow if possible. Okay. Come back tomorrow if possible. That sounds good. How about, so I don't think 3 p.m. I don't think you want another question? Okay, let's wait. The majority says wait. I may be able to do 2 p.m. tomorrow. I've got to be at the airport. So no. Tomorrow's Sunday. I feel like we should do it on the weekend. Will 3 p.m. work? Is that okay? I don't want to. Okay, you're Central, so yeah, me too. So we're on the same time. I'll do it at 3 p.m. How about that? I got to go pick up my wife from the old airport tomorrow, and then I feel like the weekend's a good day. And then it's going to drag on. I'll even do some through the weekend. So, okay, I hope this helps you guys and ladies and gentlemen. Sorry if I'm a little slow, but like I said, I'm trying to err on the side of caution. Thanks, Rosalind. That's very nice of you. I'm pretty easy. I just feel like the weekends hopefully will work best for people. So, okay, maybe tomorrow, 3 p.m. I should, if I don't post, I'll try to post some. I'll post a reminder here in a second so it's out there. Once again, those of you, if you don't mind helping me a little bit, I'm not a social media guy. I don't like it. I just don't enjoy it, so I'm not out there. If you know somebody that may enjoy this, by all means, share it. And yeah, if nothing else, I don't care if there's one person here. So, all right, you guys have a lovely evening. It's been a pleasure. Rosalind, Phaser, no one. There's quite a few others. Giselle, there's quite a few nice people. Salman, a bunch of nice people. It's very nice meeting you, and I will see you guys tomorrow. So have a good evening. If you can't be good, be careful. Bye, everybody. I'll see you soon.